All right, so let's just start our new lecture, and that is the step number 2 that we call it dark reaction. Okay, dark reaction. This is the step number 2 for photosynthesis, and we are going to talk about this reaction called dark reaction. Okay, so to me, really, to be very honest, this name is not very to my likings. Why? Because there is a reason behind it. We'll talk about that later. But to me, light independent reaction, light independent reaction, that name is more suitable. Or say the Kelvin Benson cycle, or say reductive pentose phosphate cycle. These names are more suitable than the name called dark reaction, but the more famous name is actually the dark reaction. Why I don't really like this name dark reaction is because since the light reaction gave us the idea that it was light dependent reaction, dark reaction would give us the idea that it is dark dependent. That means for a reaction to its completion, we need darkness. But that's not really true, okay? It is light independent reaction. It means whether if light is present or light is not present, it's not going to affect it anyway. So this was the beginning of that reaction. What do you do of this dark reaction? See, you have seen in the equation of photosynthesis, you have seen water. Yeah, is it visible to you? Yes, it's visible. We have seen water getting mixed with carbon dioxide, reacting with carbon dioxide and producing C6H12O6 with 6 oxygen with 6 water molecules. Okay, this was the equation that we have seen already. So this equals 12 water molecules, 6 carbon. This was the equation of the photosynthesis, and that gives us the idea that out of the 2 reactants we have for the photosynthesis, one is already used. This one is already used in the light reaction. We have seen water being used in the step called photolysis. But question is, where was carbon dioxide used? So it's certain that carbon dioxide was not used in the light reaction. Therefore, you would say that the carbon dioxide will be used in the dark reaction that you call light independent reaction. So certainly we are going to see carbon dioxide being fixed in a pentose sugar, where it will produce some carbohydrates. Certainly it's an anabolic reaction. Recall again, my dear students, that you have from light reaction 2 things available. You have 9 of your ATPs, okay, 9 ATPs, and you have a coenzyme and a DPH. And how many of it? 6 of these. So this is the product of the light reaction. And remember, light reaction runs only for the reason to let the dark reaction do its work. So right now we have 9 ATPs that have come from the light reaction, the first half of the photosynthesis, and we have 6 NADPHs that is also coming from. These are also coming from the first half of the reaction called light dependent reaction. Okay, so we are going to start this reaction by writing here ribulose 1,5 biphosphate. Ribulose 1,5 biphosphate. See, many of you don't really take the cycles to be very easily understood. And the reason why behind this is because you think that these reactions got names, and names are probably very difficult for you to memorize. This is why you don't really appreciate having these cycles being mentioned in your book. But I tell you, these are just few names. If you memorize this, the cycles is going to certainly get easy for you, okay? So we are going to talk about ribulose first. Now, in chapter number 2 of book 1, if you could recall, we have classified monosaccharide on the basis of the number of carbons. And if you could see in the 5 carbon categories, we have ribose and ribulose. Okay, ribose was an elder sugar that was also a 5 carbon containing sugar, and ribulose is also a 5 carbon containing sugar, but that certainly is a cattle sugar. So it's a 5 carbon sugar that has to be 5 carbon in its structure. There has to be like 1, 2, 3, 4, 5 carbon in the structure. When I'm saying 1,5 biphosphate, that means on the 5th of its carbon we have a phosphate group, and on the 1st of its carbon we have another phosphate group. So we have 1 on the 1st, 5 on the 5th. What's bi? It's 2 phosphates. Biphosphate, ribulose 1,5 biphosphate is the starter of the reaction. It's a reaction between ribulose 1,5 biphosphate and a carbon dioxide, and there are 3 certain reactions. So we'll be talking about that. Now, how many molecules of these ribulose 1,5 biphosphates are? There are 3 molecules of it. Now remember, how many carbon do we have right now here? Is 5 carbon. 1, 2, 3, 4, 5 carbon. And there are how many molecules? 3 molecules. 5 carbon to each ribulose 1,5 biphosphate, and there are 3 molecules of 5 to each, 10 to 2, and 15 carbon. 15 carbon to 3 ribulose 1,5 biphosphate. Now what are you going to see is ribulose 1,5 biphosphate is going to react with 3 carbon dioxide. 3 carbon dioxide. These are atmospheric carbon dioxide, so they are going to be fixed. Okay? The reason why we have stomata is for fixing these carbon dioxide molecules. So see, 3 ribulose 1,5 biphosphate are going to mix with 3 carbon dioxide molecule, and suddenly they're going to give you something, okay? So it's like one ribulose 1,5 biphosphate reacting with 1 carbon dioxide and giving you two of some compounds that I'm going to just mention. So there are 3 separate reactions, okay? So we'll just go with this particular product here. We have a product called 3-phosphoglycerate. Now I don't mind writing it glycerate. You can also write it glyceric acid. Okay. Now what glyceric acid is? It's a 3 carbon acid, and on the 3rd of its carbon we have a phosphate group. So what do you see? You see since it's a 3 carbon, and I have told you already, ribulose 1,5 biphosphate, 1 molecule, 1 carbon dioxide is going to give you two molecules of 3-phosphoglyceric acid, glycerate. Why? 5 carbon and this 1 carbon, 6 carbon, 5 carbon and this 1 carbon. This is just 1 carbon, 3 molecules, but just 1 carbon in each molecule. So each 1 molecule of ribulose 1,5 biphosphate interacting with 1 carbon dioxide, and suddenly it's going to be 6 carbon in the structure. But the 3-phosphoglyceric acid has only 3 carbons. Where have these other 3 carbons gone? Actually, these are 2 molecules to each ribulose 1,5 biphosphate and carbon dioxide. So if these are 3, these are going to be 6. I hope I'm making sense here. 1 ribulose 1,5 biphosphate, 1 carbon dioxide is going to give you 3-phosphoglyceric acid. The second will give you 4, and the third will give you 6, 3-phosphoglycerate, right? I don't mind writing it, glyceric acid. So there's going to be six of these molecules. So see, this is 15 carbon, 5 to each, 3 molecule, 15 carbon, and we have 3 carbon in the carbon dioxide. And how many carbon dioxide do we have here? We have some 18 carbon in the structure. We have some 18 carbon in 3-phosphoglycerates, 6 molecules. Now this is the first reaction. This is the reaction between carbon dioxide and ribulose. This perhaps is why ribulose 1,5-biophosphate is called carbon acceptor in the Calvin-Benson cycle. The enzyme, expected to carry out this reaction is called Rubisco. Why would you call it Rubisco? There is a reason behind it. We will be calling it Rubisco. What is the reason behind calling it Rubisco? It's actually ribulose 1,5 biphosphate carboxylase oxygenase. That has to be an oblique here. Oxygenase. So what you've done? You have done ribulose, Rubisco with this R and with this U, this ribulose. Bi for this bi, okay. Biphosphates. And this C is for its action to fix carbon dioxide. Carboxylase, the enzyme that fixes this one, has the activity of carboxylase. Sometimes it behaves as picking up some oxygen, so we can call it oxygenase. So the name Rubisco is given to it because it can behave as a fixer of carbon dioxide, at the same time the fixer of oxygen. So we call it fixer of carbon dioxide, the carboxylase, and the fixer of oxygen, the oxygenase. So now we have a situation of this 3-phosphoglyceric acid with 3 carbon in structure, and on the third carbon there is a phosphate group. And how many molecules do we have here? 6. Now, if I want these molecules to be phosphorylated, all 6 of these are to be phosphorylated, then this compound is going to be 1,3-biphospoglycerate or glyceric acid. 1,3-biphospoglyceric acid. This is what we are going to see here. The question is, there was only 1 phosphate on the third carbon. We have now 1 phosphate group on the first carbon too. Now, this was the 3 carbon structure. There was 3 carbon structure, and you had a phosphate group on the third one, 2. On the third carbon, you had a phosphate group. What do I see here right now is we have a phosphate group here on the first carbon. And it's just not 1 molecule, it's just 6 molecules. So certainly we have taken some 6 phosphate groups from some compound, and these compounds are nothing else but the ATPs coming from the light reaction, the first half of the reaction. So ATP with a 3-phosphate, 6 of these went into the reaction, or like reacting with the 3-phosphoglycerate. 6 of these, when they react together, they make 6 of these. But what really has happened is the phosphate group, the 3, see? Adenosine tri, this was adenosine di. Where have we left our 1 phosphate group is on the first carbon of 8 sugar. So we have 1,3-biphosphoglyceric acid. I hope I'm making sense. No. See, on the third carbon we had a phosphate group. What's the change? The change is here. The change is here on the first carbon. I hope I'm making sense here. Let's just make those phosphate group to be red here. Say this is red is the phosphate The pink is the phosphate group, and this is the same phosphate group that we have mentioned here. Question is, we have another phosphate group is on the first carbon of the sugar. Where has this phosphate come from? It has come from the 6 molecules of ATP interacting with 6 of these, and each of those 6 has a first carbon being phosphorylated by 1 ATP. Okay, 1,3-phosphoglyceric acid, 1 ATP making 1,3-biphosphoglyceric acid, 1,3-biphospho. This one phosphate has been taken by 1 ATP and an ADP. ADP with 1 phosphate short. So where has this 1 phosphate gone? To the first of 1,3-biphosphoglyceric acid molecule. I'm making sense, right? Okay, so how many ATP have you consumed right now? 6. And each one of these ATPs have been consumed to shift their phosphate group, and all 6 of these have to be giving its phosphate group to the first carbon of the 1,3-biphosphoglyceric acid. Now this is something that you get right now. You have 1,3-biphosphoglycerate, a compound that's mentionable here. What is next, sir? What is next we are going to see here? We are going to see some molecules of NADPH, NADPH. Those molecules certainly have also come from what? From the light reaction. And how many are there? 6. 6 of those NADPHs giving their hydrogen and electrons to this compound. NADP is formed. And how many are these? 6 are these. I hope making sense. So what do I have? I have 1,3-biphosphoglycerate now being reduced by NADPHs, and certainly there are 6 1,3-biphosphoglycerate. So in order to reduce 6 1,3-biphosphoglycerate, we needed 6 NADPHs. And we did get NADPHs, 6 NADPHs from the light reaction of the photosynthesis, the first half of the photosynthesis. How many NADPs you get? Here, 6. Now you see you have 1, 3. You have 1, and you have a phosphate group on the first carbon, and you have a phosphate group on the third carbon. But what do you have next is a compound called 3-phospho. Is it visible to you? No. It's not. Yes, now. 3-phosphoglyceraldehyde. Now it's a compound that only has a phosphate group on the third carbon. The question I have to ask myself is, where has this one, the phosphate group on the first carbon has gone? This is only the phosphate group on the third carbon. Where has this gone? And it's just not one molecule. It's just 6 molecules. Certainly 6 phosphates are missing. Now, I have to tell you that this reduction, this is the kind of reduction in which you also remove 6 inorganic phosphates from the reaction. Okay, and that has to be no surprise for you. Why? Because you have seen a similar type of reaction in the glycolysis. I hope you could remember this. Immediately after the cleavage, you have a compound form 1,3. I'm just writing here 1,3-biphospho glyceric acid, and that was formed out of the compound called 3-phosphoglyceraldehyde. 3-phosphoglyceraldehyde. Please make sure that you go to that page and actually see what I'm talking about. I hope making sense. You're not supposed to just say, okay, sir ne padha diya and that's fine. No. You have to literally go into those pages where this is mentioned. Now this was an aldehyde, okay, and what you did was you made an acid out of it. How could you do it, sir? We could do it if we let our NADs reduce. NADs reduced into NADHs. And since the molecules were 2, so 2 molecules were formed, NAD was also 2. If you could recall that we have only one phosphate on the third carbon. Now we have two phosphate. We have a phosphate group on the first carbon as well. So where has that phosphate come from? It has come from the two inorganic phosphate that have gone into the reaction. And this is why we have it only has on the third carbon. Now we have it has a phosphate group on the first carbon too. So if you compare this reaction and this reaction, they both are apparently same. How? This reaction is this reaction, yeah, and these reaction, like this reaction is the reversal of this reaction. So if we just go backwards, 3-phosphoglyceraldehyde, 3-phosphoglyceraldehyde. If I go backwards, go 1,3-biphosphoglyceric acid, 1,3-biphosphoglyceric acid. And since the six inorganic phosphates are coming out, obviously we are going back, so these will go in. Yeah? You're seeing NADPH is being oxidized to NADP. Certainly, it is going to be opposite of it, NAD. The only difference is we have 6 inorganic phosphate here, we have 2 here. We have NADPH here, we have NAD here. That's with the phosphate, that doesn't have a phosphate. I hope I'm making sense here. So what do you see? You see an acid turning into a sugar, where here you have seen a sugar converting into an acid. Yes? 3-1,3-biphosphogycerate is an acid, and it has changed into 3-phosphoglyceraldehyde. How many molecules? Certainly 6. You don't really have a carbon dioxide removed from the reaction, okay? So there's no carbon dioxide remover. You have 3-phosphoglyceraldehyde, a compound, right? Now what do you see? You see the same has gone to produce the ribulose 1,5-biphosphate again. So I'll just write again one more time. 3-phosphoglyceraldehyde. What's the change in the number of carbon? No change in the number of carbon. There was no change in the number of carbon from moving from 1,3-biphosphoglycerate to 3-phosphoglyceraldehyde. It was again the same 3 carbon in the structure. The same 3 carbon in the structure we have here and there. On the third carbon, we have a phosphate group. On the third carbon, we have a phosphate. I hope making sense here. Now, what did I do? I have made it again. Why, sir? It's because I wanted you to know that out of those 6 molecules, only 1 has gone out of the reaction. Only 1 has gone out of the reaction, and remaining 5, this was 6, it was 6, 1 has gone down, remaining 5 have gone to regenerate ribulose 1,5-biphosphate. How many carbon? The same, it's the same structure. And on the phosphate, on the third carbon, we have a phosphate group. So it's a triose, yeah, 3-phosphoglyceraldehyde, and we can have another triose also to proceed that reaction. We'll talk about that later. So out of those 6, 1 has gone out. 1,3-GP, glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate has gone out of the reaction. Okay, and remaining 5 have gone back into the reaction so that they could regenerate ribulose 1,5-biphosphate. So what's the product actually? 3-phosphoglyceraldehyde or 3-phosphoglyceraldehyde, 3-GP, 3-glyceraldehyde phosphate, I should say G3P, glyceraldehyde 3-phosphate. Yeah, this is nothing. Glyceraldehyde 3-phosphate, that's the sugar, or 3-phosphoglyceraldehyde. You can also call that 3-GP, you can call it. Okay. 3-PG, 3-phosphoglyceraldehyde. Okay, fine. Let's just go back to this part of the reaction. You have 5 of these. So how many carbon do we have right now? It's 18 carbon. Here we have 18 carbon. Okay, and how many we have here? It's 18 carbon again. So there's no change in the number of carbon here. I hope we are making sense, okay? Here we have the carbon short. Why? Because we have 3 carbons 3 carbons have gone out of the reaction as product. 1,3 biphosphoglyceraldehyde, 3-phosphoglyceraldehyde is gone out of the reaction. So 3 carbons are missing. Out of 18, if 3 are gone, this will be 15 carbon structure. A 15 carbon structure. Why? One has 3, and these are 5 molecules. 5 3 times is 15 carbon, and each of that has a phosphate group. So we have 5 molecules. And each molecule has a phosphate group on the 5th carbon. So certainly we have 5 phosphate group here. And if you calculate the number of phosphate here, these are 3 molecules. Each has 2. 3 molecules, each has 2. So 1 has 2, 2 has 4, and 3 has 6. We have here a 15 carbon structure with 5 phosphate. Yes or no? Yes or no? Phosphate. And we have a 15 carbon structure, but with the 2 phosphate, like 6 phosphate. 6 phosphate. So what's missing? 1 phosphate is just missing. We have 5 phosphate, we have 1 phosphate. Now see, now this cluster certainly has to change into something that they call ribulose 1,5 biphosphate, but certainly it has to make another intermediate compound, and that will make 1 phosphate here. So 2 phosphates are gone, 2 phosphates are gone, and we have added 3 phosphates back in. So 3 phosphates will be put into the reaction. 3 ATPs will go into the reaction, and you will have 3 ADPs coming out. Now you probably will say, sir, excuse me, sir, we only need 1 phosphate. Why would you put 3 phosphate into it? The question. Okay, so the answer to this question is there was an intermediate product that people, don't really know, and they don't actually make the name to this compound. That removes 2 inorganic phosphate. So 2 inorganic phosphates have gone. Now we needed 1, 2 missings again. So we have now 3 needed phosphate which are being given to this compound by the 3 ATPs. This is some mistake that people don't really consider. Why? Because a small chain, 2 inorganic phosphates gone, but replaced by the 3 again. So what do we have now? This is our Kelvin Benson cycle. Okay, we will be talking further about it. We will not let it go. Okay, this is our Kelvin Benson cycle. So 3 ATPs are consumed back again to produce ribulose 1,5 biphosphate. 15 carbon done. 5 phosphate, but 2 are missing. Then again, how many? 2 are missing. 3, but you get 3 more. You get 6 of these phosphate group. I hope we have made sense. Now see, we have understood what is the reaction, how things have gone. Now what we are going to do is we are going to name these reactions. Name these reactions. See, ribulose 1,5 biphosphate, when picked up carbon dioxide, we name this part of the cycle also. Okay, this part. And where 1,3 biphosphoglyceric acid change into 3-phosphoglyceraldehyde, we also have to name this part of the reaction too. And where 3-phosphoglyceraldehyde change into ribulose 1,5 biphosphate, we also have to give the name to this part of the reaction. So we have classified 3 different steps in the Kelvin Benson cycle. The first one was carbon fixation. Carbon fixation. A lot of people call it carboxylation. I don't mind that. Carboxylation. The step number 1. What is that step, sir? The step where ribulose 1,5 biphosphate got mixed with 3 carbon dioxide and produced 3-phosphoglycerate. Since they picked up these carbon dioxide, so you can call it carbon fixation. Or you can call it carboxylation because it's a carboxylation of ribulose 1,5 biphosphate to 3-phosphoglycerate. Step number 2. Step number 2 is not this one where the phosphorylation has. I wish that if that would also be a step, but they have not given any name to this part of the reaction. Okay, they've given this part of the reaction a name, and what's that? Reduction of 1,3-biphosphoglycerate to 3-phosphoglyceraldehyde. Not just that long, but just reduction. Reduction. Now, what is reduction? Is when you give some of your hydrogen or electron. So NADPH has given its hydrogen and electron to 1,3-biphosphogycerate acid and made 3-phosphoglyceraldehyde of it. So this is NADPH going in, which means it's a reduction of 1,3-biphosphoglycerate, and NADP has come out. So it's a reduction phase, step number 2. This half of the reaction is called reduction. Okay, step number 2. Step number 3 is regeneration. Regeneration. That's the step number 3. Why is it called regeneration? Because out of the 3-phosphoglyceraldehyde, you are regenerating again ribulose 1,5-biphosphate so that you could pick up carbon dioxide. So this reaction is called carbon fixation. Let me just write here. Fixation. You can call it carboxylation also. So this reaction is called carbon fixation. Correct? Can you see it? Yes, you can see it. Carbon fixation. This reaction. We'll just try to find space for writing the reduction phase. Here, reduction. Now this phase here is called reduction. What phase? Which phase? The phase where 1,3-biphosphoglyceric acid changed into 3-phosphoglyceraldehyde. Okay. And what about this reaction? 3-phosphoglyceraldehyde changing into ribulose 1,5-biphosphate. It was regenerating ribulose 1,5-biphosphate. So the reaction is called regeneration. This will be a little big name. Regeneration. Now, what's regeneration? Is the formation of something back again. So this is the regeneration phase. So what we have done in this entire cycle is we have started naming it, all right? Let's just name them with the pink so it just get prominent out of this whole thing here. So the first reaction was the carbon fixation. Okay, just memorize it. That is the fixation of carbon dioxide into ribulose 1,5 into 3-phosphoglyceric acid. Who picked it? Ribulose 1,5-biphosphate picked it. And this was the second reaction called reduction. Reduction of 1,3-biphosphogyceric acid into 3-phosphoglyceraldehyde. And this reaction was the regeneration. Out of the 3-phosphoglyceraldehyde, you were regenerating ribulose 1,5-biphosphate. So this was called regeneration. Unluckily, this hasn't have any name. Okay, if I was the author, if I would was the one that has found those reactions, I would certainly give this name as phosphorylation. Okay, so these are the compound. These are something that you have to memorize. If you don't really have to memorize all this, अगर आप ये memorize करना नहीं चाहते तो भी ये ठीक है, कोई ऐसा खास बात नहीं है। क्यों भाई, खास बात क्यों नहीं है? इसलिए क्योंकि इतना कोई एग्जामिनेशन में इसका इंटरमीडिएट आता ही नहीं है। आप लोग क्या करते हैं, इतना डीप पढ़ते हैं, इतना अंदर चले जाते हैं, अपना भी सर खपाते हैं, मास्टरों का भी सर खपाते हैं, और इवेंचुअली ना फिर आपको पता चलता है कि कौन सा क्वेश्चन आना है, सारा गड़बड़ हो जाता है। जो आम सीधे क्वेश्चन होते हैं आप उस पर ध्यान देते नहीं हैं और आप चले जाते हैं कि इस पर इतने बड़ी मुसीबतों पे ये ला वो ला फलां पता नहीं क्या करते रहते हैं। और जब कभी सादा सा क्वेश्चन आ जाता है उसको भी आप CID की तरह देखते हैं, वो क्या है उसका नाम बंदे का, उसकी तरह देखते हैं कि यार इसमें कोई बड़ा सस्पिशियस रिकॉर्ड सर ने छुपाया हुआ है। कुछ भी नहीं होता है भाई, सिंपल से सवाल होते हैं। ठीक है, एंट्री टेस्ट ले रहे हैं, कोई आपको MBBS की डिग्री थोड़ी दे रहे हैं। सही है। सो दिस इज समथिंग दैट वी हैव। ये वो ATPयाँ हैं. These are the ATPs that have come from the light reaction. Those are the NADPHs that have come from the light reaction. And these were the ATPs that have come from the light reaction. So the green thing, the 6 ATPs and these 3 ATPs, 9 ATPs, we'll just write here, 9 ATPs just here. You just write 9 ATPs here, and we have 6 NADPHs have come from this cycle here. Okay, तो जो चीज़ें निकली हैं उनके बारे में भी हम देख लेते हैं, मगर यहाँ पर we have just talked about 9 ATPs that have gone into the reaction, 6 NADPHs that have gone into the reaction. So this is the total this is the product that have come from the light reaction. I hope we have made sense. इसको भी कार्बन डाइऑक्साइड को भी इसमें बना देते हैं. That's also the substrate here. ठीक हो गया जनाब? तो दिस इज़ द होल रिएक्शन. बाकी चीज़ों को मैं नहीं करता हूँ, रंग नहीं करता हूँ, खाली इसको अगर मैं चाहूँ तो मैं कर लेता हूँ. ये वो स्टेप हैं जो आपने याद करने हैं बेटा. कार्बन डाइऑक्साइड का फिक्सेशन, जिसको कार्बन फिक्सेशन कहते हैं, ये स्टेप नंबर 1 है केल्विन बेंसन साइकिल का. रिडक्शन स्टेप नंबर 2 है, और रीजेनरेशन स्टेप नंबर 3 है. समझ में आ रहा है अरसलान माय बॉय? सही है, समझने की कोशिश कर. ओके, एंड डोंट यू एवर से दिस. चीज़ें बोला ना करो ऐसे कि मुझे नहीं आ रहा है, या जस्ट डोंट टॉक अबाउट इट. ओके, जस्ट डोंट टॉक अबाउट इट. जस्ट से आता है, एंड आई कैन डू इट, एंड दिस हैज़ टू बी ओनली आई कैन डू इट. इस पूरे रिएक्शन में बेटा आपने देखा कि आपने 6 ETPयाँ यहाँ लगाई. सही है, और कार्बन डाइऑक्साइड देखिए ना, 6 कार्बन डाइऑक्साइड आर यूज. आपने तो 3 इस्तेमाल किए ना. सो व्हाट डू you need certainly another cycle go on with that. And if one cycle gives you 1 triose sugar, this one, yeah, kadra, 1 triose, certainly 2 will produce another triose, and then only you can make a hexose. आप तो हेक्सोज बनाना चाह रहे थे ना, यू आर मेकिंग हेक्सोज हियर. आपने तो ट्रायोज बनाया है, तो सर हम हेक्सोज कब बनाएंगे? जब ये एक बार फिर चलेगा और आप 3 कार्बन डाइऑक्साइड और इस्तेमाल करेंगे, और ये सब कुछ डबल होने शुरू हो जाएगा. यानी 6 of these ATPs and 3 of these ATPs, 9 for 1 cycle of the reaction, 18 for the 2 cycle of the reaction. That means this is going to be 2 times of 9. This is going to be 2 times of 6. It's an 18 ATPs and some 12 NADPHs are used to make 2 trioses, which mean 1 hexose. Triose is 3 carbon sugar. Hexose is 6 carbon sugar. तो आपने तभी triose बनाया. 3 carbon sugar, ये तो प्रोडक्ट नहीं है इसका, यह है, ये तो C6 है ना, ये C3 थोड़ी है. तो यू हैव टू रन अनदर साइकिल फॉर दिस. इसका मतलब सब कुछ डबल हो जाएगा, है ना. कार्बन डाइऑक्साइड डबल होगी तो 6 हो जाएंगी जनाब, है ना. ये 3 है तो ये 6 हो जाएंगे. या आप एक साइकिल एक बार फिर बना दो दोबारा, तो ये 6 और 3 9 का दुगना हो जाएगा 18. ये हैं 6 एक साइकिल में इस्तेमाल हो रहे हैं, दूसरे में ये 12 हो जाएंगे. आई होप वी हैव मेड सेंस हियर. ट्रायोज इज नॉट द प्रोडक्ट. The product of the photosynthesis is not a triose, it's a hexose. Hope I'm making sense here. So for this, a reaction has to go 2 times, okay? So this was the Kelvin-Benson cycle. I hope आपको ये बातें समझ में आई होंगी. इंटरेक्ट क्लास के अंदर हम लोग इसमें डिस्कस कर लेंगे. सही है?